Hi all, welcome back to Matlab tutorial on Tute Fulcrum. This session is on Matlab data types. Matlab does not require any type declaration or dimension statements. Whenever Matlab encounters a new variable name, it creates the variable and allocates appropriate memory space. Let's see the available data types in Matlab. MATLAB provides the following data types. Every data type stores data in the form of a matrix or array. In this session, we will be discussing about numerical data types, character and string, and logical data types. Structure and cell arrays, which are the heterogeneous data types available in MATLAB, will be discussed in the coming sessions. Let's begin with numeric types. Numeric class in MATLAB includes integer and floating point numbers. Integers include signed and unsigned integers. So you can store an integer data as int8 means signed integer 8 bits or uint represents unsigned integer 8 bits. Similarly, you can store them as 16-bit, 32-bit or 64-bit. Both includes signed and unsigned. Floating point numbers can be stored as either single precision or double precision floating point values. Single precision floating point values takes 32 bits to store your data. In that, the 31st bit represents the sign. If it is 0, it represents a positive data. If it's 1, it represents a negative data. Whereas for double precision floating point values takes 64 bits to store the data. 63rd bit represents the sign of the data. If the sign is 0 indicates positive and if it's 1 indicates the data as negative. 23rd bit to 30th bit represents exponent value in the case of single precision floating point data, whereas 52nd to 62nd bit is used for representing exponent in the case of double. Same way, 0 to 22 bit represent fraction f of number 1.f in the case of single precision floating point values, whereas 0 to 51 bits are used for representing the fraction of a number 1.f in the case of double precision floating point values. By default, MATLAB stores all numeric values as double precision floating point. Let's write the code and understand this. Let's take a variable a. Let me initialize with a numeric value 12. MATLAB provides various functions for identifying the data type of a variable. So let's use a function class. So if I say class of a, this will give me the data type of the variable a. So my answer is double here. It's because by default, MATLAB stores all numeric values as double precision floating point. MATLAB provides provision to convert one data type to another. That is, suppose if you want to change the default data type. I'm going to change the data type double of the variable a to signed integer. Let's say I'm going to modify this data type of a from double to signed integer 8 bits. I can do like int 8. Specify the data type to which you are converting and then specify your existing variable name. So let me take the result to a new variable s. Now this s will be changed to signed integer 8 bits. So present data type of my variable a was double, which is now converted to signed integer 8 bit. Let's verify this. Now if you check the data type of s, you can see it will be int 8, which means it is representing a signed integer 8 bits. You can check the size of your variable using the function size. So if I say size of a, you can see your output as 1, 1. This is representing your row size and column size, which means a is stored as 1 row and 1 column. It's because every data type stores data in the form of matrix or array in Matlab. Let's see about precision in storing floating values. Suppose you have an expression t is equal to 1 divided by 7. Your output is 0.1425 etc. You can format your output using the command format. If I say format short and then if I give t, you can see the t is now in a short format which is represented with 4 decimal places 0.1429. So if you look at the two outputs here, you can make out that the first one requires more memory and is more precise than the second one. So make use of double in the first case and single in the second case. So you can check the data type of t using the class function. So it is giving me the output as double. So if you want to store t with fewer number of decimal places, you will not require the double data type. So you can change this double to single. So how to change? Just use single and then specify the variable name t. So now t is changed to the data type single. Another method of changing the data type from one data type to another is making use of the cast function. So let me take an example. Say r is equal to 89. So we know that the data type of r will be double, the default. Yes, now from this double, if I want to change the data type to unsigned int 8, let's make use of the cast function and analyze our output. So let me use a variable w to store the result. Now I'll make use of the cast function. So cast, specify your variable name. So I have r here, comma, specify the new data type to which you are changing within quotes. So I'm going to change it to unsigned int 8 bits. So cast, specify the first argument as the existing variable and second is the new data type to which you are changing the data. So now if you check the data type of w, you can see that it will be changed to unsigned int 8. So there are multiple ways by which you can change the data types. Now let's see about characters and strings. So let me take variable a. Let me initialize it with the character r. So the character must be enclosed within single quotes. If you check the data type of a using the class function, you can see it is char, representing the character type. If I have initialized a with a group of characters, it becomes a string. You can check the data type of a, even it returns char. So here also you can change the data type from char to, say you want to change to an integer or number. So you can make use of the function. So b is equal to, here you have a function str to num. If I say str to num of a is of type char, this will be changed to a number. So let's check the data type of b. You can say it is double. So it has changed the data type from char to double. You can do the reverse operation also. That is, you can change an integer to a string. For example, if I have s is equal to 90, which is storing an integer entity, I can convert this integer to a string. Say if I say t is equal to, I can use the function int to str of s. This will convert the integer s to a string. If you check the class of s, you can see it as char. So you have changed the data type of t from integer to character. So now coming to logical data types. Logical data types are used to store Boolean values. Boolean values means true or false, so zeros and ones. So if I say a is equal to true, true is a Boolean value. So the data type of A will be logical. Let's check using the class function. So class of A, you can see the output, it is logical. Suppose if I have an expression like this, A equal to say 10, B equal to 90. If I write C is equal to A greater than B. If you check the class of A, you can see it is double. Class of B will be double because they all hold the numeric value. So the default numeric data type is double. But if you check the class of C, that will be logical because C is holding a logical value. It is checking a relation between A and B, which results in a logical output. So A greater than B. A is 10, 10 greater than 90. The result will be either true or false. So in our case, 10 greater than 90. The result is false. So it is holding the data type as logical. So you can change the data type for logical as well. So if I say D is equal to cast, so I am changing the data type of C. So this logical entity, if I am changing to say int 16, you can check the class of D. It has changed to signed integer 16-bit. So this is about the numeric, character and logical data types in MATLAB. So keep watching for the heterogeneous data types in MATLAB, that is structures and cell arrays. Thank you so much. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get updated whenever we upload our new videos. Thank you.